Good morning, my favorite APES class, my favorite class period. Don't tell the other classes. I wanted to talk a little bit about population. So that's what we're going to do today. So if we take a look, we have this figure on the screen. And at first glance, I'm like, oh my God, there's a bunch of dots. I'm not really sure. So let's take a look at the axes first. So anytime we're approaching a graph, we want to take a look at the axes. So at the x-axis we have here where it says income, right? We have poor on the left. So anything from 1,000 to 4,000 GDP. So GDP is gross domestic product. This is a measure of how big your overall economy is per capita. That means per person. So if you have a low GDP per capita, that means your country doesn't have a lot of money. And then when you spread it out amongst all the people, then you really don't have a lot of money versus countries that have a rich GDP per capita. And so like this would be like how much income as the individual is bringing in. So for example, if your parents make $40,000 a year, that's their GDP per capita. It's not exactly the same, but that's how we can kind of think about it. So this is kind of like how much does the average person have? So that's our x-axis. Our y-axis, we can say, okay, the bottom is very sick, the top is very healthy, and then we even have this axis up here at the top. Okay, so we see we define these as level 1, level 2, level 3, and then level 4. And we'll talk a little bit about that. That's kind of relating to the demographic transition model. And so this is kind of they're judging life expectancy around GDP. So how long can you expect to live? And is there a relationship between how long you're living and the wealth of your country? And so as we see here, these countries down in the corner, Central African Republic, Somalia, Mozambique, Afghanistan. So these ones have low health. So their life expectancy is very low and their income is very low. Also, the color of the dot tells us where we find that country. And then the size of the dot tells us how big that country is. So for example, Central African Republic is really small, Afghanistan's really big, India's huge, China's huge. The next largest circle is actually here, the United States. The United States is the third largest country in the world. We have somewhere around 335 million people. So here we see North Korea, decently sized, has a long life expectancy, but very poor. They're a communist country. As we move a little bit here, we see China, right? China has long life expectancy and their income is moving up. Russia's life expectancy is a little bit lower, but their income is a little bit higher. So typically we call these countries here that have a higher GDP, we call them developed countries. These countries down here, you guys probably call them third world. We're not going to call them that in APES. They're developing or less economically developed, LED, less economically developed countries. These here and that are in the middle, the Philippines, Indonesia, Egypt, Morocco, Vietnam, India. These are all moderately developed, okay? We would classify anything that's pretty much here and to the right as a developed country, right? You guys know these, the UAE, Germany, Australia, Switzerland, Italy, Spain, here's Qatar. They have so much money because they have so much oil. And so here's just a little explanation. And so probably this is something that you knew, that the United States has a decent life expectancy and we have a pretty good income, right? Japan's is slightly less than ours, but their life expectancy is a little bit more. And we can talk about the things that contribute to that. So we're not really sure how many people can live on Earth. Currently, there's 7.8 billion people here on Earth. We see that here there was always under like 2 million years ago, there was always way under 1,000. Here's where agriculture first came into invention, or people started with agriculture. We see that it slowly started to kind of rise and then it kind of falls, but it mostly stays here really low. We see a little dip here in the Black Plague. I don't think that we'll see a dip, but there will be, as we expand this out, due to the coronavirus, there's definitely going to be an impact on our population maths. And then here 1600, and if you notice right after the 1600s, we had this massive increase, and that's due to the Industrial Revolution. Okay, so in order to understand the impact that the human population has on the environment, we have to understand what drives human population growth. And that growth is we want to talk about how big is the overall population. We want to talk about births and deaths rates. We want to talk about fertility, the number of babies born. We want to talk about life expectancy, and we can also talk about migration, both immigration into and then emigration exiting. And so all of this work is what we call demography. It's the study of human populations and human trends. And again, we've already seen this, but just as a little side note that the United States, or I'm sorry, we hit 7 billion in 2011. It took 25 years to add the second or the third 2 billion, and then 16 years later, we're already at 7.3, and now it's even 7.8. So we're moving very rapidly. Okay. And so here we see our overall, so again, I'm going to see another graphic. Let's take a look at the axes. So I have time, that makes sense because we have a line graph. This one x-axis says population growth rate. And so that goes with this line. So I'm going to use this first line up here is the population growth rate. And then this one says population size. And so then this one goes with this line. So don't be surprised if you see some graphs that have an x and a y, two y axes. So if you notice here, my population growth rate was increasing and then it dropped dramatically. I think that this is probably the invention of birth control, and then it went back up and then it slowly started to decline over time, but our population size is still increasing, okay? Human growth is not evenly distributed. 2% of the world's births are in developed countries, whereas 98% are in developing countries. We have slowed our population growth down to about 1.2%. That's for the world. And that's due to education of women. And we're talking about education in schools. We're also talking about family planning. All right, so human population growth has increased over time due to greater food productions, better healthcare, access to medicine, access to better water quality. We ultimately want to achieve this, what we call zero population growth, where two people are just having two offspring to replace themselves. Ultimately, we want this S curve to replace our J curve. And so here, example, if you notice, right, and this one has a couple of layers. So again, we have time on the bottom here. We have population on our y-axis. If we are to had a low fertility rate, this is where we're seeing in 2050, we've already surpassed that. So maybe it could start to even out or even decline. I doubt we're going to hit that. Medium fertility rate, 9.4 here in 2050. High fertility rate, 11.2. If I had to guess, I would say we're somewhere between these two, okay? Don't forget that the different colors represent the different countries. So like this is all Africa, and then the difference between the red and the top of the blue, that's Asia, that's China, and that's India. And then just this part of the yellow. So they like build on top. They're not cumulative, they're each individual. If you were to read them, does that make sense to you? So like here, this is the top of the yellow is Europe. I'm going to go all the way across. Okay, it looks kind of to me like 7.5. This one is like maybe 8.1. So it's like 0.6 billion people live in Europe. So it's not cumulative. They're just divided up by countries. Okay. So how do we know how long it's going to take for us to double? So we're going to use this formula. So it says at today's 1.2% global growth rate, the population will double in 58 years. And so this is a formula that we need to be familiar with. This is the first one that you need to write down. It needs to be in your notes. Again, your test for this, just because we're remote, is open note. If we're not remote, it will be closed note. But you need to know this formula. So the formula is how long, it's what we call doubling time. How long is it going to take our population to double? It's super simple. You're going to use a calculator. And it's just going to do 70, the number 70 divided by the growth rate. So for example, if we back up once, my growth rate is 1.2. To find the number it's going to take to double, 70 divided by 1.2. You're not going to convert this into a decimal. You're going to leave it as a percentage. So 70 divided by the growth rate is the number of the doubling time in years, how long it's going to take the population to double. So China's growth rate is 0.7%. How many years until it doubles? 70 divided by 0.7 is, I don't know, math. There's something 100 years. 70 divided by 0.7 is 100 years. Sudan's population doubles every 35 years. What is its growth rate? So now I'm going to set up the opposite. 35 is equal to 70 divided by X. And so its growth rate is 2%. Okay. Some things that we need to talk about. What contributes to that growth rate is immigration going into a country, emigration leaving a country, the crude birth rate, the number of individuals that are born per 1,000 people, and the crude death rate, the number of individuals that are born per 1,000 individuals. And so we can find the growth rate. We're going to calculate that R. Here's another formula that you're going to have to know, and then I'll end this video because it's getting a little long. So our two formulas for figuring out the growth rate. So I wanted to figure out this number here, this 0.7, this 1.2. How do I figure out that number? Here's my formula. Births plus emigration minus deaths plus emigration divided by the total population times 100 will give you my population growth rate. Or if you have the crude birth rate and crude death rate, you're just going to divide by 10. And that's because this is per 1,000. Let me see if I have a slide. So again, we already did this. Sudan has an estimated population growth rate of 2.5%. How many years will it take the population to double? So I'm just going to do 70 divided by 2.5 should give me 28. Okay. And with this, oh, let me finish these. A town has a population of 3,000 individuals, 150 were born, 30 moved out, 25 moved in, 75 people died. What is the growth rate? So what formula am I going to use? I'm going to, again, attempt to draw on this. So this gives me real numbers. So I'm going to use the births plus immigrations minus deaths plus emigration divided by the total pop times 100. This growth rate is also going to give me doubling time. So let's see. I'm not sure what's on the next slide. Okay. So I'm just going to go back and now I'm just going to plug in. So I know that I have 100 and, oh gosh. Okay, so I have 150 that were born, plus how many 25, minus how many 75 died and 30 moved out, divided by my total population of 3,000. So the kids used to have to do this math by hand, but now we're going to plug it into a calculator. And so that's going to give me, I'm just going to clear off, that's going to give me 175 minus 105 divided by 3,000. So 175 minus 105, 70 divided by 3,000 times 100. So 70 divided by 3,000 times 100. Did I do this right? So then I'm going to end up with 70. So like here, I could cross out some zeros. And that's going to give me 70 divided by 3. That's going to give me math that I can do, which is 2.3%. So then this problem says a town has a CBR of 50 and a CDR of 15. What formula am I going to use? What's the population growth rate? So I'm going to use crude. I'm going to use the formula. Oh gosh, I'm like on the struggle bus today. It's because I'm not used to being remote. So crude birth rate minus crude death rate divided by 10. So I'm going to plug in 50 minus 15 divided by 10 gives me 45 divided by 10, which is 4.5. Okay, let's back up. How come sometimes you divide by 10 and sometimes you divide and then multiply by 100? And so that has to do with the fact that in this first one, let's see. So here in these two, right, if you have the total population is 1,000, right, because that's what crude birth rate means, And then you just go and you multiply by 100. If I just cross out those 2 zeros, that's the same thing as dividing by 10. So that's how come we can get the second formula from the first formula. So I know this was a little bit long. Hopefully it was helpful, and I'll check on you guys in class.